Orbiting the magnificent gas giant planet Jupiter is the mysterious icy moon, Europa, a seemingly frozen world about the same size as our moon. With a surface temperature of about -256 degrees Fahrenheit, and a location that subjects it to a relentless pummeling of radiation, Europa might appear barren at first glance. But despite the harsh conditions it faces, this fractured moon is one of the most promising places to search for alien life. So how could life survive on such an extreme moon? And if it does exist, what might it look like? Many spacecraft have passed by Europa during their missions, but it was NASA's Galileo spacecraft that truly expanded our understanding of this icy moon. Galileo discovered the first solid evidence that an enormous ocean exists beneath Europa's surface. An ocean possibly containing 2 or 3 times as much water as all of Earth's combined. Arriving at the Jovian system in December 1995, with the aim of exploring Jupiter and its large moons, Galileo made multiple close passes by Europa, coming as close as 125 miles. It captured detailed images of Europa's frozen terrain, revealing its cracks, ridges, and jumbled-up landscape, along with intriguing evidence of what might be happening below its crust. Galileo confirmed that Europa was geologically active. Its close-up images showed enormous cracks in the moon's surface that had separated, with dark, icy material flowing into the opened gaps. Similar to previous spacecraft, Galileo also found only a few impact craters, which should accumulate over time due to meteorite bombardment over billions of years, much like our own moon. However, Europa's smooth surface suggests relative youth, with something potentially erasing any large craters, such as icy volcanic flows. One of the most significant measurements made by the Galileo mission showed how Jupiter's magnetic field was disrupted in the space around Europa. This measurement strongly suggests that a unique type of magnetic field is being generated within Europa by a deep layer of some electrically conductive fluid. Based on Europa's icy composition, scientists believe the most likely material to create this magnetic signature is a global ocean of salty water. There are even images from the Hubble Space Telescope that seem to show massive plumes of water vapor erupting from Europa's south pole. Although unfortunately, they're not high resolution enough to be definitive. But if Europa's surface is solidly frozen, how could a vast ocean of salty water exist beneath it? And could life have really started in such an unusual environment? While Europa's icy shell is as hard as a rock, its interior is warmer due to tidal flexing. The side of Europa facing Jupiter experiences a stronger gravitational pull than the other side, causing the entire moon to stretch back and forth. This tidal flexing likely causes the long cracks on its icy surface and heats the interior through friction, similar to how bending a paperclip generates heat. This continuous flexing melts the internal ice, creating Europa's vast ocean. But is it feasible for life to originate on a frigid moon millions of kilometers away from the sun? Well, life as we know it requires 4 main components: liquid water, certain chemical elements, an energy source, and time. We've already established that Europa may have a massive ocean of liquid water protected beneath its crust, possibly formed just a few 100,000 years after the moon's formation, giving life, if it exists there, plenty of time to emerge. But what about the other requirements? Chemical elements and an energy source? These elements are fundamental to life and include carbon, hydrogen, nitrogen, oxygen, phosphorus, and sulfur. They're widespread throughout the universe and likely present during Europa's formation, potentially added to later by asteroid and comet impacts. One recent example of chemical elements discovered on Europa is the detection of large amounts of carbon dioxide on its surface by the James Webb Space Telescope, as shown in this remarkable infrared image. Europa appears as blue, while the carbon is depicted as white, likely originating from the ocean below. Now, let's talk about the need for an energy source. All life as we know it requires energy to survive. Here on Earth, life mainly relies on the sun for energy, such as through photosynthesis. Plants convert sunlight into energy, allowing them to grow, and that energy is then transferred to those who consume the plants. However, any potential life in Europa's ocean is hidden below the thick ice, where no sunlight can penetrate, meaning photosynthesis wouldn't work. Instead, life would have to be fueled purely by chemical reactions. These reactions could occur in various ways, such as from Jupiter's powerful radiation bombarding Europa's surface or, more likely, from the warm rock on the seafloor. As Europa orbits around Jupiter, its interior flexes, forcing energy into the Moon's interior, which then seeps out as heat. The more the Moon's interior flexes, the more heat is generated. If Europa's rocky ocean floor is heated by tidal flexing, this process could potentially provide energy in the form of available chemical nutrients in hydrothermal vents. This type of process is observed here on Earth, where life thrives around hydrothermal vents. These vents are like bubbling cauldrons of energy, spewing out superhot water heated by a layer of molten magma below Earth's surface. Within these plumes are a soup of chemicals that certain life forms can thrive on. While these chemicals would be toxic to humans, these organisms can convert them into energy through a process called chemosynthesis. This process ultimately powers entire ecosystems around hydrothermal vents found in the deep, dark regions of our oceans, where sunlight cannot reach. These vents are the only places on Earth where the ultimate source of energy for life is not sunlight, but the Earth itself. In these extreme deep ocean ecosystems, we find huge red-tipped tube worms, ghostly fish, strange shrimp with eyes on their backs, and other unique species. So, life as we know it on Europa could indeed be possible, but what might it look like? To get an idea, we could look within one of the deepest, darkest points on Earth, the Mariana Trench. The Challenger Deep, the deepest point in the Mariana Trench, lies 11 kilometers or 7 miles below sea level. It's challenging to comprehend just how deep that is, but if you were to place Mount Everest there, the peak of the mountain would still be more than 2,000 meters, or 6,561 feet, below sea level. However, that's nothing compared to Europa's ocean, which ranges anywhere between 60 to 160 kilometers, or 40 and 100 miles deep. Despite this vast difference in depth, the conditions between the two environments may still share some similarities. Picture a vast, seemingly endless pitch-black void filled with crushingly cold seawater. This is the type of oppressive environment life within the Mariana Trench has had to adapt to. But dive deep enough, and you'll encounter some of the strangest creatures on Earth. Creatures so bizarre, you'd think they were from Europa. Take the snailfish, for example, a species that holds the record for the deepest living vertebrate. It's been found at depths of over 8,000 meters, below sea level. This odd, translucent tadpole-like fish contains chemicals that help keep its membranes and cell walls flexible, preventing them from being crushed by the immense pressure. But there are creatures that dwell even deeper. In the deepest region of the Mariana Trench, the Challenger Deep, 3 organisms are most commonly found. First are the xenophyophores, the world's largest living single-celled organisms, resembling spherical or frilly sponges about 20 centimeters across, or 8 inches. It's uncertain exactly how these peculiar creatures survive, but it's believed they produce slime that absorbs microbes from the sediment around them. Then there are amphipods, shrimp-like scavengers that thrive in the deep seas thanks to exoskeletons containing aluminum. How these little critters acquire this metal remains a mystery, but scientists speculate they use sugar-based chemicals in their guts to extract aluminum ions from the seafloor as they feed on debris raining down from above. The third are called holothurians, a species of deep-sea sea cucumber. They are the most alien of the known animals in this region and are highly diverse, appearing with spiky, brightly colored skin or smooth, translucent skin. Vast fields of sea cucumbers have been discovered at the bottom of the Mariana Trench, resembling cows, grazing over pastures as they feed on bacteria and decomposing matter on the seafloor. So, if life has managed to thrive in the deepest oceans of Earth, could it have also done the same in the even deeper oceans of Europa? Until we send a probe capable of drilling through the thick layer of ice encasing it, we may never know. Europa could be full of alien creatures, or it could be completely barren. However, that burning question may be answered in the next few years, as the European Space Agency, along with NASA, each have 2 separate major missions to Europa. The first from ESA is called JUICE, and has already launched in April 2023, aiming to arrive in 2031 for a double flyby with the goal of collecting new data on the chemistry of the icy moon. Then we have NASA's Europa Clipper, designed to determine once and for all whether this icy moon's ocean is habitable. It's scheduled to launch in October 2024, but won't arrive until April 2030. These exciting missions should complement each other. But neither will be able to confirm if aliens exist here, only whether the icy moon has the right conditions to support life as we know it. If we did eventually find some form of life on Europa, it would probably be in the form of microbes surviving around a hydrothermal vent. But if it can be demonstrated that life formed independently, regardless of how complex it is, in two places around the same star, it would then be reasonable to suggest that life springs up fairly easily once the necessary ingredients are present, and that life might be found throughout our galaxy and the universe. What do you think about this? Leave it here in the comments and take the opportunity to like the video and subscribe to the channel for more videos like this.